Assalamu alaikum students. I am good students. I hope you too. Now my dear students, our topic is solid state. Our topic is solid state and now page number is 110. Solid state. Now solid state, students, solid have fixed shape and volume. I studied previous class, solid have fixed shape and volume. The molecule in solid are extremely closer to each other without leaving space between them. The molecule in solid are closely packed due to stronger force of attraction. Solid state. Now rigid, fixed shape, and also fixed volume. Solid state. Now student, I hope you also understand the solid state. Pure solid have sharp melting point. Solids have definite shape and definite volume. Shape and volume definite. Now the molecules can vibrate and rotate in their fixed position. Now last point is the molecule are unable to move freely as they have little space between them. Students, I hope you understand the state of solid. First of all, rigid. What is the meaning of rigid? Sakht yani sakhti. Fixed shape or fixed volume. Now the next is properties of solid. Solid. First of all, melting point. Now students, melting point, हम बचपन से पढ़ते आ रहे हैं कि melting point क्या है. Now the temperature at which a solid start melting. Temperature at which a solid start melting. Solid start melting and coexist in equilibrium with liquid state is called melting point. Students, you get it? When temperature is raised, the kinetic energy of molecules increase. When temperature raise, kinetic energy of molecule increase, definitely increase when continuous heat, when heat continues supplied to solid molecule leave their fixed position and become mobile. At this stage, solid start melting. Melting point of different solids are given. Now, table 5.5. Sugar melting point, Celsius is in 185. Chocolate 36. Mercury minus 38.83. Sodium chloride 801 and water last now 0. Student, rigidity, what is the meaning of rigidity? I told you rigidity, the meaning of rigidity is hard molecule. Hard, Urdu meaning is sakht. Rigid sakht and rigidity sakhti. The molecular arrangement of solid is closely packed. The molecular arrangement of solid is closely packed. Due to this, solid are not mobile. Mobile, they exhibit vibration at fixed position. Therefore, solids are rigid in their structure. Students, you get it? The molecular arrangement of solids closely packed molecule. are packed to this solid are not mobile. Now, is that clear? Rigidity. Now the next is density. Now students, our topic is density. Density is solid are typically denser. Solid are typically denser. That's the meaning of, what is the meaning of denser? Denser meaning ठोस, meaning of denser, solid. The solid are typically denser than the liquid or a gas. Solid are typically denser compared to than the liquid or gas. Molecules in solid are more tightly packed together because of the greater intermolecular forces. Students, greater intermolecular forces. Molecules in solid are more tightly packed together because of the greater intermolecular forces. Due to this reason, solid have higher density. Solid have high densities among three states of matter. Some densities are shown in table 5.6. Now, aluminum, iron, gold, sodium chloride, sugar, page number 111. Table 5.6 densities of solids. Now, the next is types of solids. Student, page number 112, types of solids. Types of solids. Types of solid. The solid are classified on the basis of arrangement of molecules. There are two types of solids which are as follows. Crystalline, one of crystalline, and second one is amorphous. Crystalline solid, it is crystalline. Now, crystalline, what is the meaning of crystalline? Crystalline meaning crystal, and the process of crystallization. The solid in which molecules are arranged in definite three-dimensional geometrical pattern. Three-dimensional geometrical pattern is this. Geometrical pattern. Three-dimensional geometrical pattern are called crystalline solid. Student, you get it? Crystalline solid. The arranged molecule in solid are bonded by plane surface called faces which intersect each other at a particular angle. The melting point of crystals are sharp. Melting point of crystal are sharp. We can say that sharp, high, larger. Sodium chloride and diamond are common example of crystalline solid. Diamond, figure 5.16, and sodium chloride, figure 5.15, are the common example of crystalline solid. Students, crystal. Now I told you about crystal. Crystal, the arrangement of molecule, the arrangement of molecule is called crystal, figure 5.14. Now amorphous form, crystalline, amorphous form as this. Amorphous. Now next topic is amorphous solid. What is amorphous solid? Define amorphous solid. The solids in which molecules are not arranged in geometrical pattern. Is that clear? The solids in which molecules are not arranged in geometrical or crystalline solid in which molecule arranged in definite three-dimensional geometrical pattern are called crystalline solid. And molecules are not arranged in geometrical pattern are called amorphous solid. They do not have sharp melting point. Crystalline solid have sharp melting point. Amorphous solid do not have sharp melting point. The example of crystalline solid sodium chloride and diamond. And example of amorphous solid is plastic, rubber and glass are the example of amorphous solid. Example of amorphous solid. Example of amorphous solid is glass, rubber, plastic. Now student, is that clear? Figure 5.17. Now difference between amorphous and crystalline solid. Difference between amorphous and crystalline solid. Now next topic is allotropy. Allotropy. Allotropy students, allotropy means, Urdu meaning is Behrupiyat. Urdu meaning is Behrupiyat. Now, what is allotropy and what is Behrupiyat? The existence of an element in more than one crystalline form. Exist करते हैं element. Now, more than one crystalline form. More than one crystalline form. More than one crystalline form of the element are called allotrop or allotropic form. We can say that the chemically same and physically change. This is also called allotropy. Chemically react same and physically change are also called allotropy. Now, this happens when the atom of the element are bonded together in a different way. Different bonding, different way, and different bonding arrangement between atom result in different structure with different chemical and physical properties only. Some elements like sulfur, phosphorus, carbon and tin are elements which show allotropy. Sub examples: sulfur denoted by S, phosphorus denoted by P, carbon C and tin Sn are examples which show allotropy. Now, allotropy of diamond. This is allotropy of diamond. Diamond where the carbon atoms are bonded together in a four-cornered lattice arrangement. Diamond shape where the carbon atoms are bonded together in a four-cornered lattice arrangement. This is called diamond. Allotropy of diamond. Now, allotropy of graphite. Allotropy of graphite, allotropy of graphene and allotropy of fluorescence. Now, graphite where the carbon atoms are bonded together in sheet of a six-sided lattice. This is sheet of a six-sided lattice, and now graphene single sheet, and fluorescence where the carbon atoms are bonded together in sphere. Sphere means round, cylinder or X-shaped formation. Now students, page number 114, our topic, second last topic is plasma state. Student, you know fourth states of matter is plasma state. Fourth states of matter. Students, fourth states of matter. This one is plasma. Plasma state. English scientist William Crookes identified the fourth states of matter known as plasma state was discovered by adding energy to a gas. Adding energy to a gas. As a result, some electrons left their atoms and formed positive and negative ions by ionization. In plasma, these charged particles react strongly to electric and magnetic fields. In plasma loses heat, the ions will reform into a gas emitting the energy which had caused them to ionize. Students, we can see that fourth states of matter, plasma state, are super hot state. Super hot state. Super hot state. Now gas molecules more heat. The particle is this, free movement. Heat around 10,000 Celsius degree centigrade. All molecule dissociate in all gas molecule dissociate in atoms. Now all molecule dissociate in atoms. Now some are positive, some are negative, and some neutral. Some neutral atoms. Students, is that clear? Fourth states of matter, super hot state. Gas molecules are more heated than gas molecules are spread freely movement around 10,000 degrees centigrade. All molecules dissociate in atoms. All the gas molecules dissociate in atoms. Some are positive, negative, and some neutral atoms. Student, some examples of daily life plasma state. First of all, the artificial man-made use of plasma include fluorescence light bulb, neon sign. Is that clear? Light glowing. For example, open the use of plasma display of television or computer screens. The plasma lamps or globes are popular in children toys and room decor. Is that clear? Now fifth and last topic is our last topic is BOS, BEC, Bose-Einstein condensate. Fifth states of matter, BEC. Fifth states of matter, BEC. BEC. B for Bose, E for Einstein, C for condensate. Students, two scientists, Satendra Bose and Albert Einstein. Satendra Bose and Albert Einstein discovered another state of matter in 1920, but they did not have the equipment and facilities to make it happen at that time. Students, now they dissolved, that is plasma, are super hot and super excited atoms. We can say that plasma are super hot and super excited atoms. The atom in a Bose-Einstein condensate are totally opposite. Totally opposite is that they are super unexcited and super cold atoms. Super cold and also unexcited atoms. Let's explain. Absolute zero is a temperature. Temperature is zero. Zero temperature meaning temperature where all atomic activities are stopped. Zero temperature, all activities stop. Let us explain condensation first. Condensation happens when several gases molecules come together and form a liquid. Several gases molecule come together and form a liquid. It all happens because of loss of energy. Gases are really excited or energetic atoms. When they lose energy, they slow down and begin together. They can gather into one drop. One drop. Now, for example, when you boil water, water vapor in the form of steam condenses on the lid of pot, vapor cool and become a liquid. Again, you would then have a condensate. BC happens super low temperature. Or students, we don't see it common example in daily life. We don't see Boss Einstein condensate common example in our daily life. Bose-Einstein condensation happen at super low temperature. When we get temperature near absolute zero, the meaning of all activities are stopped. All molecular motion is stopped due to depletion of energy and atom begin to clump. The result of this clumping in the BEC in common, we cannot see this state in observable nature because it is very difficult to reach at very low temperature under normal lab conditions. Students, now you get it. Now that's it.